So let's say that we have a logarithm that doesn't have base e. It's not a natural log, and we'd like to take the derivative of it. Well, we're going to use this change of base formula to convert the log of any base into a ratio of natural logs. So here we go. If I've got the log of x base 3, that's equal to the natural log of x over the natural log of 3. And I can rewrite that as 1 over the natural log of 3 times the natural log of x. That's just a constant. That's like a coefficient. And so the derivative of that will equal our coefficient times the derivative of the natural log of x, which is 1 over x. And we get 1 over x natural log of 3. Now we can generalize this rule right here, which says that the derivative of the log of x base a is equal to 1 over x natural log of a. Once you know that, then you can solve any logarithmic equation. So let's convert this using laws of logarithms to that. And that means that dy dx is equal to 5 over x natural log of 6. So what about the derivative of an exponential function whose base isn't e? Well, let's take the natural log of both sides. So I get the natural log of y equals the natural log of 3 to the x. That means the natural log of y is x natural log of 3. Now let's do implicit differentiation. So I get 1 over y prime equals, now the derivative of x times a number is just the number, right? And so when I solve this for y prime, I get y natural log of 3. Okay, so what is y? Well, remember that y is our original exponential. So this is 3 to the x times the natural log of 3. And we can generalize that rule. The derivative of a to the x is equal to a to the x times the natural log of a. So the derivative of 3 to the x is 3 to the x times the natural log of 3. Now, the chain rule applies just like it always does. So if I have y equals 7 to the negative 4x, then y prime would equal 7 to the negative 4x. Then we multiply by the natural log of 7, and then we multiply by the derivative of negative 4x. And if you want to put all that in this order, you can do that. Doesn't really matter. Anyway, that's y prime. Okay? Alright, now let's say you're faced with this. Now this looks like it's going to be a chain rule with a quotient rule inside it, and it could be a real mess. But use the laws of logarithms to your advantage. Let's split this up into the log of x squared base 3 minus the log of x minus 1 base 3. And then this 2 here can come around front. And now we're ready to take the derivative. So that's going to be 2 over x natural log of 3 minus 1 over x minus 1 natural log of 3. Okay, we can also use logarithmic differentiation to find the derivative of a function that has a variable raised to another variable. So let's take the natural log of both sides. Oh, I don't want to get ahead of myself here. This is going to be the natural log of x raised to the x minus 1. I can take that x minus 1 and put it around front. Okay, now we're going to do implicit differentiation. So the derivative of the natural log of y is 1 over y prime. And over here I have to do the product rule. There's u and there's v. Remember that it's u prime v plus u v prime. So the derivative of x minus 1 is 1 times v will be the natural log of x plus u times v prime. Okay, and then solving for y prime, I get y times all of this. And y is our original function here. So we'll put that in our final answer. And that's called logarithmic differentiation.